Hello and welcome everyone. So after understanding how do we measure seismic waves and record earthquakes through equipments like seismographs, where do we find sensors, recorders and timer. So now we come to the point of the size of earthquake that is measured in the seismograph or through any scale that measure earthquake. So the size of earthquake is given into two terms. One is the qualitative term and another is the quantitative term. Now the qualitative term is the intensity of earthquake and quantitative term is what? The magnitude of earthquake. Just like in your room, the room where you are, if you are using a CFL valve, the magnitude of earthquake can be compared to the watt of the CFL, power watt of the CFL. If CFL has got 20 watt CFL or 14 watt CFL, 16 watt CFL, that means that can be compared with the magnitude of earthquake. Means magnitude is somewhere or other related with the energy released in an earthquake in a quantitative manner. Okay. Similarly, the power of the CFL valve is somewhere or other related with the energy being consumed by the CFL per unit time. Okay. So this is the relationship here. Whereas in qualitative term, the intensity of light that you are getting on your book from the CFL decreases as you increase your distance from the CFL. Similarly, the intensity of earthquake is reduced from severe at the epicenter to the weak intensity if you go on increasing your distance from the epicenter. Okay. So in qualitative term, the damage being caused by the earthquake or the effect of the earthquake is measured in intensity or quality. Okay. So we will see both these terms in detail here. Okay. And these two useful definitions of the size of earthquake are sometimes being confused. Many people are confused that we call size of earthquake into two terms, that is intensity and magnitude, but many of them are confused. So as a civil engineer, we must know the difference between the two. Where is the fine line of difference? What is intensity of earthquake and what is magnitude of earthquake? How do we measure them? Okay. So let us begin with the intensity of earthquakes. So the intensity of an earthquake refers to the degree of destruction caused by it. See, it's a qualitative parameter. Okay. Okay. Degree of destruction being caused by it in a location. Now this degree of destruction depends on various factors. If the ground is loose, so the degree of destruction will be very severe. So intensity depends on not just earthquake, it depends on various things, but it's a qualitative parameter of measuring size of earthquake. And in other words, intensity of an earthquake is a measure of severity of the shaking of ground and its attendant damage. This of course is empirical. As I said, it is empirical. Okay. It is difficult to determine what intensity it is to some extent, because the extent of destruction or damage that takes place to a construction at a given place depends on various factors, and some of these factors are what? Distance from the epicenter. As I said, at the epicenter the damage is severe. As you go on increasing your distance from the epicenter, the intensity of earthquake will decrease. Second is the compactness of the underlying ground. If the underlying ground beneath the structure is loose, then the intensity will be severe. The structure will shake in even a weak earthquake. Okay. And if the ground is very compact, then the intensity will be low. Now third is the type of construction. Which type of construction? RCC or wooden structure or even moment resisting frame or ordinary moment resisting frame, like different type of construction that you have studied in earthquake resistant design of buildings. Fourth is the magnitude of earthquake. Now intensity of earthquake do depend on the magnitude of earthquake, okay, here, and we will study the relationship between the two also. Fifth is the duration of the earthquake. If the earthquake of even low magnitude is for a long duration, then even a magnitude of lower magnitude earthquake can cause severe damage if its duration is too large, okay. So intensity do depends on the duration of the earthquake, and it also depends on the depth of the focus. Which type of earthquake it is? A shallow focus depth earthquake, intermediate focus depth earthquake, or deep focal depth earthquake. So depth of the focus also determine the intensity of earthquake. So you can see that intensity of earthquake depends on several factors, and it's completely empirical to a lot of extent, that it's completely empirical to determine what exact intensity of earthquake is at a certain point during an earthquake. So intensity is generally depicted by Roman numerals. It is always depicted by a Roman numerals, like as we used to denote our class standard 6, 7, 8, 9, 10. So intensity also varies from 1, 2, 3, 4 up to 10th, okay. So it is represented like this, okay. You see this Roman numerals, okay. So this is how intensity is depicted, and it is always a whole number. It is never a decimal number, okay. It's always a whole number, and the range is from 1 to 10. So MMI scale, Mercalli indices scale, here it is a qualitative analysis, and it says that intensity is weak. Intensity is weak when it is equal to 1, it is moderate when it is almost 2, 3, like you can see all these are qualitative parameters, strong, severe, very severe. As you go on increasing the intensity from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the intensity is growing from weak to very severe. Now of course we measure epicentral intensity sometimes as I naught, and I naught is given in Roman number, it's a complete whole number. But when we do some calculation, in calculation we have to write I naught in Arabic numbers 1, 2, 3, that is, if it is intensity is 6, then it has to be written as 6 when we are going to do some calculation, okay. You can't do the calculation with the help of Roman numbers. So this is Arabic number, okay, and this is Roman number. So the relationship between the earthquake magnitude and intensity is given by this formula. This is very good formula, and you can note this, that equivalent earthquake magnitude is equal to 2 by 3 I naught plus 1. Here I naught is epicentral intensity. Epicentral intensity means intensity at the epicenter, and this has to be put in Arabic number, Arabic whole number, and 2 by 3 I naught plus 1 will give us the equivalent earthquake magnitude. So this is one of the important formula, and it is an empirical formula, there is no proof as such, you can remember this. Now in the same MMI scale, intensity of earthquake is also given by, now how do we calculate this I? How do we calculate this I? If we have to calculate I, then in I can be calculated using this formula. I is equal to log to the base 10, 14, now log of 2 to the base 10 multiplied by u naught. Now u naught is the maximum ground velocity in centimeter per second. Note the unit. Unit is in centimeter per second, okay. And then we will get the intensity of earthquake, and if intensity come as 8.65, so you have to write intensity not as 8.65 and neither it will be equal to 8, okay, but it will be equal to like Roman number, okay. Intensity is this 8, okay. This is clear to you. Now we come to the second term of measuring the size of earthquake, that is the magnitude of earthquake. So as we have discussed, it's a quantitative measurement of earthquake size. So magnitude of an earthquake is related to the amount of energy being released by the geological rupture causing it, and is therefore a measure of the absolute size of the earthquake without any reference to distance from the epicenter. It has nothing to do with the distance from the epicenter. It just tells us what amount of energy has been released by the geological rupture, and this strain energy is accumulated due to the movements of the rock, and when it reaches the ultimate value, rock fractures and the strain energy is released, and that is measured in quantitative term, and that is called the magnitude of earthquake. So, and it has nothing to do with the epicentral distance or any distance. So, while earthquake intensity is depicted in Roman numerals and is always a whole number, magnitude is depicted in Arabic numeral and need not to be a whole number, okay. So magnitude need not to be a whole number and it is represented in Arabic numeral, just like you have heard magnitude of 6.5 has a strike a place in Uttarakhand. So that means this is magnitude, okay. This is the amount of energy. So similar to intensity scales, over the years a number of approaches for measurement of magnitude of an earthquake have come into existence. So the famous method of measuring the magnitude scale is the Richter magnitude, okay, Richter magnitude, and it says that a workable definition of magnitude was first proposed by Charles F. Richter, and he based the data from Californian earthquakes, defined the earthquake magnitude as logarithm to the base 10 of the largest displacement of a standard seismograph, and this was his equipment's parameters, okay, situated 100 kilometer from the focus, and he got this value, okay. So he gave this formula that magnitude of earthquake, which is represented here by term m, is equal to logarithm to the base 10 to the of the largest amplitude. A is the largest amplitude here, largest displacement or largest amplitude of the displacement curve of the seismogram, okay, seismogram that you have that he obtained from his Wood-Anderson seismograph, and these were his parameters. Mass of the pendulum bob was 2800, T was 0.8 second, and damping was nearly critical 0.8, and distance was 100 km from the focus. So he got this formula and he gave this formula for the Richter magnitude of earthquake as per his equipment. And here A is the largest amplitude, and this amplitude has to have in micron, and we know that 1 meter is equal to 1000 mm, okay, and it is equal to 10 to the power 6 micrometer, or 1 meter can be said as it is equal to 10 to the power 6 micron, okay. So A denotes the amplitude in micron, okay, 10 to the power 6 meter, and 10 to the power 6 micrometer, okay. So micron is 10 to the power minus 6 meter, recorded by the instrument located at an epicentral distance of 100 kilometer, and m is the magnitude of earthquake. When the distance from the epicenter at which an observation is obtained other than 100 kilometer, so if the site where we are doing this measurement of magnitude of earthquake, if it is other than 100 kilometer, then a correction factor is also introduced in the equation and it is given as below. So this is this. Now m is equal to m delta minus 1.73 log to the base 10 of 100 by delta. Okay. So m delta is what? Now this m delta is, this is m delta. Okay, this is m delta. So m delta is equal to log to the base 10 of maximum amplitude in micron minus 1.73 log to the base 10 of 100 by delta. Delta is what? Delta is the distance, delta is the distance from epicenter in kilometer. Note that this is the distance from epicenter in kilometer, not in meter and neither in micrometer. And m delta is the magnitude of the earthquake calculated for earthquake using the values measured at a distance delta from the epicenter. Okay. So the graphical form of this procedure is given in this figure, and you can see this is the distance and in kilometer being given here in logarithmic scale, and this is magnitude and this is the amplitude in millimeter, and this is S and P wave. Basically P is what? P is primary wave and S is secondary wave. So you can see there is a time gap between arrival of P and S wave, and this time gap is used to calculate the hypocentral distance. Okay. So corresponding to this value of distance, magnitude is obtained here for corresponding to this amplitude, maximum amplitude, and this is being recorded on the histogram here. Okay. You see this maximum amplitude is where? This is maximum amplitude. You can see this is the maximum amplitude here. Maximum amplitude is here, amplitude is said to be 23 mm, and this is scaled here 23 mm, and corresponding to this distance it is obtained that earthquake is having magnitude somewhere near to the 5. Okay. And how this graph is made? This graph is made with the help of this formula which we have explained just now. So because of the logarithmic nature of the definition, a difference of 1.0 in the magnitude represents a difference of 10 in the seismograph amplitude. You can understand because it's a logarithmic graph, and magnitude observations by different recording stations usually differ quite widely, often by as much as 1 magnitude, which is later corrected in and taking into account the recordings from a large number of instruments. So a large number of instruments give us a better result of magnitude. Now there is another term by which we measure the magnitude of earthquake, and that is called as moment magnitude. Because over the years scientists observed that different magnitudes scale had saturation point, and the magnitudes estimated by different approaches did not point to a unique value of earthquake size. Just like the Richter magnitude saturates at about 6.8, and the surface wave magnitude, this is another scale for measuring earthquake magnitude, it saturates up to this value 7.8. In addition, these magnitude estimates did not have a linear relationship with the energy released due to earthquake rupture. Now as we studied that earthquake magnitude is the measure of amount of energy being released in an earthquake, but these magnitude scale were not having a linear relationship with the energy being released in an earthquake rupture. So to address these shortfalls, scientists like Hanks and Kanamori in 1979 proposed a magnitude scale, and this is now most prevailing is the moment magnitude. It has two terms, one is the moment and another is the magnitude, based on the seismic moment due to earthquake rupture. And the moment magnitude is given by this formula, mw is equal to 2 by 3 log to the base 10 of m naught minus 9.1. Okay, this will give us the value of moment magnitude. Mw is what? Moment magnitude. And m naught is the seismic moment, and its unit is Newton into meter. Okay, because why Newton into meter? It is a unit of what? Moment. Moment is what? Force into displacement. So Newton into meter. This is seismic moment. Okay, so this m naught is being calculated by this formula. M naught is equal to rock rigidity modulus. Rock rigidity modulus is represented by letter mu, and this is in the unit of Newton per meter square. So rock rigidity modulus has to be multiplied by the fault area, the area of fault through which the energy is being released, and this area should also be in meter square, and the distance of slip that has occurred in an earthquake, and this distance has to be have in meter. So when you multiply Newton per meter square with meter square and with meter, so this meter square get cancelled, and you get the value in Newton per meter. So this is seismic moment. Okay, so you can write m naught is equal to mu is the rock rigidity modulus into area, fault area A into slip distance d. So this is the formula for m naught. Okay, and this m naught has to be used in this formula for calculating moment magnitude. So this is how we calculate moment magnitude. And if you see this numerical also, here it is asked to calculate moment magnitude of an earthquake with the rupture area dimension of length 35 km. This is the rupture area, yani fault area. Length is 35 km, width is 15 km, and slip is 1 meter. And modulus of rigidity mu is 3.5 into 10 to the power 10 Newton per mm square. So length of rupture area of fault is given 35 km, width is given 15 km, average slip is 1 meter. This is equal to d, and if you multiply both of them, you will get the A. So seismic moment is equal to mu into length into width into slip, and mu is written here. Now length is converted into meter, and width is also converted into meter, and slip is already in meter. So this comes into Newton per Newton meter. Now earthquake magnitude, this is called which magnitude? Moment magnitude. Okay, moment magnitude mw is equal to what? 2 by 3 of log to the base 10 of 1.84 into 10 to the power 19 minus 9.1, and this comes as value 6.8. So this is how we calculate moment magnitude as a size of earthquake. So this completes the entire study of seismology, starting from generation of earthquake in faults, ridges and plate boundaries, to the propagation of earthquake as elastic stress waves, and then to the measurement of seismic waves. And there are in terms of qualitative like intensity, and in terms of quantitative as magnitude and moment magnitude. So this completes the study of earthquake engineering introduction as far as our syllabus is concerned. So we will meet with an assignment video in the next class. So till that, stay tuned and stay safe. Thank you.